Okay, welcome to Note 6.2, kind of continuation, but yeah, what we're going to talk about today is polynomials, the linear factors, sketching them, end behavior, turning points. Really what we're doing is we're finding all of the critical points that exist for a polynomial if you're going to graph it. And that's really what our goal is here, to graph these. So our goal of graphing should be completed today. We've done investigations on end behavior. We've done some talks about linear factors. Today we're going to talk about putting it all together and sketching it. So really we're tying everything together today. So let's get right down into it. First things first, you can see here what we're looking with is a couple basic functions. These are the same ones that you probably saw in your investigation, your end behavior investigations. They're not terribly difficult. So let's see if we can find some information on these. First thing that we want to go ahead and find are the zeros. So to solve for zeros, it's pretty basic. Anytime that you have a linear x for both of these are both super easy. You know that your zero is going to be 0. So my x0, I should probably call it an intercept, same difference, right? So I'm going to go ahead and call that 0. So I know that both of these have a point at 0. So there's our zeros. I'm going to label this as I go. This one has a multiplicity though, and this is the other piece of information that came from our notes, is multiplicity is if a zero is repeated. So you can have as many zeros, and we'll get to that, as the degree, but if there's multiplicity, you might not see them all. What does that mean? I don't know. I jumped the gun a little bit, so let's backtrack. Let's just go back to what we know. Multiplicity for this one should be 5, right? So now that we've got our multiplicity, let's talk end behavior, okay? So end behavior then is looking at the leading coefficient. Since there's only one in this both of these polynomials, the leading coefficient for this is positive, right? There's your positive, and it happens to be a degree of 4, which makes it even. So for this particular one, it's going to be end behavior. I'm using EB for end behavior, if you didn't figure that out, is going to be positive, but it's going to be odd. Now, when we have that, we have a little pattern that we did in our investigation, and we know that that means now that if it's positive and odd, it starts low and ends high. So we know what the ends do, and we know where there's 1 point, and it's a fifth part. We'll talk about turning points when we get there, but let's keep this pretty basic. So let's mark in our end behavior. I know that I'm going to start low, and I'm going to end high. I actually draw that in. A lot of times I'll start with the end behavior. Now I'm going to fill in my intercepts, so I'm going to go ahead and doodle this up. I know I need to go through that point, and I'm going to doodle this over. This is a sketch. It may not be completely accurate, but I have a pretty darn good idea of what's going on with it. And that's all this is. It's not a full graph. It's as close as we're going to get for the information that we can see. All right, so there's a couple other ones we can look at. Here's a linear factor. This is an actual linear function because it's not squared or cubed or to the 4th power, right? So you can see here we've got a linear factor. If we solve that out, 4x minus 8 equals 0. If we hadn't solved that, 4x equals positive 8 divided by 4x equals 2. So there it is. But this 2 doesn't have any, there's no degrees, there's no multiplicity like that. So it's actually just 0. It's actually odd, though, degree, and we'll talk about that in a minute. End behavior for this one, then, looking at the leading coefficient, it's positive and it's odd because it's a degree of 1. Sorry if I'm going fast. I feel like you guys know this stuff, so I don't want to take my time here. These are going to be long notes. I didn't tell you that already. So odd positive is right here, so we know that if it's odd and positive, it's going to start low and end high. If you forget that, go back to those notes, take a look, memorize them, write them on the top of these notes, whatever you got to do. We know that it's linear, so we can cheat a little bit. We'll go through 2 and we just draw a line. Actually, since it's linear, we know a little bit more than that, right? We know that our slope is up 4 over 1, right? So up 4 over 1, you can see I actually plotted those points there. So let's talk about a quadratic. How does a quadratic look if we wanted to sketch it? Well, we know how to graph a quadratic, so that's kind of something that we should already be good at. But for intents and purposes of calling it a polynomial, side note, let's take a look at these. These are all polynomials. 4th degree of x, a 5th degree of x, 4x minus 8, a linear, that's a polynomial. Polynomial is anything with an x in it, right? Just to kind of play devil's advocate here, exponential would be something like 2 to the x. That would not be a polynomial. Something in the denominator, if we had x in the denominator of a fraction, that would be called an inverse function. That's not. If we had an absolute value of some sort, that would not be polynomials. So not polynomials for these. Just to kind of give you an idea. So quadratics you're really familiar with, linears you're really familiar with, cubics, 4th powers, 5th powers, those are the polynomials. Basically, this applies to every polynomial that you can think of, even the ones that you're familiar with. So let's go ahead and do this one. We can see this here, make that adjustment. I think it's already made in your notes that those are negatives, not positives. So for this one, to find the zeros, we would need to factor this, right? It's a simple form of factoring. So because the a value is 1, we can go ahead and go straight to the parentheses, put an x in front of both, and say what two values multiply to make -3 that combine to make a -2. Of course, that's going to be -3 and +1. They're going to multiply to make a -3, and they're going to combine to make a -2. So if we solve for those, we find out that our zeros are +3 and -1. No multiplicity because they both have a degree of 1. Okay, so far so good. So there's our zeros. We can mark those down. And again, this is just a preliminary sketching for you. This is what you know so far. We're going to add stuff to it in the next round. All right, so now that we've got that down, let's look at the end behavior. We look at the leading coefficient. So for end behavior, we've got an even degree, right, squared, and that's a positive x squared up the front, so it's positive. So even and positive should both go up. So we're going to take these two. We know that we have to end up here somehow. And so we'll talk about if these are, we should already actually know a little bit that these are crossing or touching zeros, right? They're both odd linear factors, which means that they're crossing zeros. That means that we have to go through them. And because we go through them and have to end up, the only way that we can draw it's like that. So you can kind of see everything coming together. So the next part of the notes, which we're going to jump to now, is to kind of fill in all the blanks here. So what I'd like to do is go label all of this information at the bottom here, and then we'll come back and label it up at the top so you can see what each one is, or I might go back and forth. Who knows? So linear factors, we're pretty familiar with that, right? Some form of x plus 2 or something. I'm going to write ex here so you know that's an example. That would be an example of a linear factor. They are equal to the number to the degree of the polynomial. Okay, so what does that mean? If I have something with a cubed value or something with a fourth, we know that there's going to be 3 linear factors for this one and 4 linear factors for this if these are both separate functions. Okay, so whatever the degree is, you know that you can have at least that many linear factors. Well, different linear factors. They could all be in one. Because they could have a multiplicity, which is the next point here. If it has multiplicity, you may not see all of the zeros. It could be something like this. Hey, there's 3 linear factors. It could represent that function. It's a cubic. All right. Linear factors are referred to as roots, zeros, x-intercepts, and we use the zero product property. That's what ZPP stands for with those to find the actual intercepts, right? That gets us the x-intercepts. That's how we get to them. All right, the degree of the polynomial, what does it give us? Well, it shows us end behavior, right? Because if it's positive or negative, we can tell which direction it's going. If they're even, it's the same direction. If it's opposite, they go in, or if it's odd, it goes in opposite direction. So we already know that. Even's the same, either both up or both down, and odd will be opposite, either down, up, or up, down. Okay? So next new term here is a relative maximum or relative minimum, also referred to as turning points. Same thing. They are what they sound like. Relative meaning they're not the exact highest point, but they're like a high point, or they're not the exact lowest point, but they are a low point. You can see I did a little sketch here. This is an easy way to recognize them. They're the little wiggles, if you will. The wiggles. What a good kids program, but hard to watch if you're not a kid. If you look at this, it's the point at which they turn or change directions, if you will. So for our definition, it's a vertex, right? A vertex, a point at which the graph changes from, if it's increasing, going up right here, this point, that vertex, it changes direction and now it's decreasing. So that's the point. These are what we refer to as, that would be a relative maximum because it's a high point, and a minimum would be the relative low point, or it's decreasing and it changes to increasing. So this now goes from decreasing to increasing. So you can have multiple turning points. Actually, you're going to have one less turning point than the degree of the polynomial. Where the linear factors were equal to the degree, this one's going to be one less. So if we were talking about a cubic function like this, it would be number of possible turning points would be 2. If we're talking about a fourth power polynomial like this, the maximum number of turning points for that, or relative max or mins, is going to be 3, one less. All right, y-intercept, you know that. It's the constant in standard form. Make sure you're in standard form. Okay, of course, it's where the graph crosses the y-axis. That's another piece of, and again, let's label these. Make sure that we keep hitting this. These are the critical points that we're going to use to graph these, or critical pieces of information. Some are not exactly points. All right, go back to the leading coefficient. Yep. We talked about the degree, right? Tells us end behavior. We kind of cheated a little bit. The negative and positive is for the leading coefficient, but it's all tied together. It's okay. So the leading coefficient, again, in standard form. Don't do it in any other one because it could be not the real leading coefficient. So make sure it's in standard form. The negative then, The right side goes, this is a notation you got to get used to. Sometimes they refer to this in your book, or you might see it somewhere else. We already are comfortable with this, so you know what it means. If it's negative, the right side goes down. They don't like to talk about what happens with the left. They just, because you know that if it's even, they both go the same direction. Or if it's odd, they have to go in opposite direction. So they like to talk about it on just the right side. So that's where this notation comes from. So if it's negative, the right side goes down. If it's even, they both go down. If it's odd, then it started up and it goes down on the right. Can you get it? So if it's positive, the right side goes up. So let's reverse this. So the right side would go up on the right side, and so the left side, if it's even, would also go up, and if it's odd, it would be the opposite, or go down. And again, that's decreasing, because it would be negative. So, yeah. So there we go. Now let's talk about multiplicity. I think we're pretty good with that. We did that in the first activity of the unit, but let's just review it to make sure we've got that piece together. Again, this is all of the critical information being tied together for us. So multiplicity refers to the number of times an associated factor appears in the polynomial. What? It just means, is it there once, or does it contain more than one zero? And we know what multiplicity means, anything higher than a degree of 1. If it's odd, or I'm sorry, if it's even, got off track there. If it's even, we refer to it as a bouncing zero. So it goes down, it touches the zero, and it turns around, right? And that's actually going to make a relative min or max for you if it's a bouncing zero. That's part of what it creates. If it's an odd multiplicity, so let me do some examples real quick of even. So this would be an even multiplicity, x plus 2 squared, or x minus 3 to the 4th. Those would be even multiplicity linear factors. You could even have one that looked like this. X to the 6th, right? That could be considered a linear factor with multiplicity of 6. So if it's an odd multiplicity, so for example's sake, just to stay on that track, we could say x minus 1 cubed, right? Or x plus 2 to the 9th. Those would be odd multiplicities. They would be zeros that we would cross through. However that looks, they would go through those. So that's actually a huge piece of information, multiplicity, to tell us what's actually going on in the middle of our polynomials. And end behavior does the end. So between those two, you can kind of graph all of it, and then you tie in the y-intercept, you talk about some relative maximum or minimums, and you're pretty good. So again, end behavior is determined by the leading coefficient and the degree. That's why I said that they were tied together. And then it's the path that the graph takes on both sides. But we've talked about that a little bit. All right, so let's start labeling some of this information here. This right here, let's start from left to right. So all these points right here, this one here at -1, this point here at 2, this point here at -3, these are all, as you can guess it, zeros, roots, whatever you want to call them, x-intercepts, whatever word terminology you want to use there. If we look at this point, look what happens here. We're traveling up, increasing. We hit this point here, right? This is a relative maximum, okay? Because it's the highest point, we're increasing, and then after that point, we're decreasing, okay? So let's look at this point down here. We're decreasing. We come to this vertex here, and now all of a sudden we change direction and we're increasing again. Okay, so we go from decreasing to increasing. This is a relative minimum. Okay, so now you kind of see what they look like. Now, what's the other piece that we haven't talked about yet? Well, let's change to a color that isn't the same, and that would be end behavior, and that's what happens on either end. So for this function, to make this here, look at the linear factors. 1, 2, 3 linear factors, which means that it's a cubic. Okay, and if it's cubic, we know what it's going to have a wiggle in the shape, but more importantly, how do you get the lead coefficient and degree from this? How did you know that that was a cubic? Well, if I, in my head, did the distributive property, right, for these, I know that this x is going to multiply this x and it's going to make an x squared. But then I have to distribute these two terms in there, and when I multiply this x in, I'm going to multiply an x by itself 3 times, it's going to be a cube. And then if I look at its coefficient here, it's a 1, it's a 1, it's a 1, that coefficient is not going to change. So the leading coefficient is a positive 1. So I know that this is odd and positive, so I know that the end behavior is going to start low and end high from that end behavior. And so if I have all of those pieces, and the one piece that we didn't get from this, because it's not in standard form, is the y-intercept, which is right there. I'm going to label that for you, y-intercept. If it was in standard form, and we could change that by standard form from actually multiplying the whole thing out, we would be able to mark that point as well. So that's how it all fits together. I know that was really fast. go back. I'll try to slow down the way that I talk, but it's just the way my nature is. But it's great. It's a video because now you can go backwards and replay it if you need to. These are the notes. They'll be in your OneNote, and I'm going to do part 2 here in just a split second. So I'll see you back here.